In 1984, Pontiac built the first mass-produced mid-engine sports car in American history. It looked like a Ferrari, it was priced like a Civic, and it had a nasty habit of catching fire, not metaphorically, actual flames, in the engine bay, while people were driving it on public roads, about 20 times a month by 1987. So, 1978. Pontiac is in trouble. Not the fun kind of trouble either. The brand that built the GTO, that made the Firebird a cultural icon, that once convinced an entire generation of Americans that General Motors could build something exciting, is now selling rebadged Chevrolets with different grills and hoping nobody notices. The muscle car era is dead. The oil crisis killed it. Federal emissions regulations wounded it. Corporate average fuel economy standards buried it. And GM's senior leadership is perfectly content to let Pontiac fade into the background, because honestly, they never wanted their divisions getting too exciting in the first place. Exciting cars attract attention. Attention attracts regulators. Regulators cost money. GM liked money more than excitement. But down in Pontiac's advanced engineering group, a Turkish-born engineer named Hulki Aldikacti has an idea that, by General Motors standards, borders on certifiable. Aldikacti has a master's degree in mechanical engineering from the University of Michigan, an MBA from Michigan State, and 22 years of experience navigating GM's bureaucracy. He's also got a temperament that made him unpopular with most of that bureaucracy. The man was told 3 separate times by counterparts at other GM divisions that his project had been canceled by corporate management. 3 times. He kept working anyway. His idea was a mid-engine sports car with plastic body panels on a steel space-frame chassis built from scratch, with a proper independent suspension designed specifically for the layout. In 1978 at General Motors, proposing a mid-engine anything was like walking into a board meeting and suggesting they donate the Corvette program to charity. See, GM had already rejected proposals for a mid-engine Corvette. Multiple times. The corporation's position on 2-seat sports cars was simple and absolute. The Corvette exists. Nothing else needs to. Building a second 2-seater, no matter how cheap or different, would cannibalize Corvette sales. That was the logic. So Aldikacti and his allies, including new Pontiac General Manager Robert Stempel and Chief Engineer Robert Dorn, an ex-racer who grinned ear to ear the first time he saw the mock-up, did something clever. They didn't pitch a sports car. They pitched a commuter vehicle, a fuel-efficient 4-cylinder, 2-seat commuter car that just happened to have its engine behind the driver. It would help Pontiac meet its CAFE fuel economy targets. It would be inexpensive to build. It absolutely, positively would not threaten Corvette sales. It was a sports car wearing a disguise, a wolf in commuter clothing. Dorn pointed out that with a 4-cylinder engine, the little 2-seater could deliver 31 miles per gallon in the city and 50 on the highway with the economy transmission. Those numbers would pull Pontiac's fleet average in the right direction. Senior management liked the fuel economy argument a lot more than they would have liked the sports car argument. They said, fine, build a prototype, see what happens. GM's president at the time quipped that a creative general manager and chief engineer should be able to scrape up about $1 million for a prototype. That was all Aldikacti needed. His team came back with a running prototype in less than 6 months. But here's where GM starts doing what GM does best, undermining its own good ideas with cost-cutting. The budget for the entire Fiero program, from initial design to retooling a factory, was $400 million. That sounds like a lot of money. It was not. By early 1980s, GM standards, $400 million, was a fraction of what the corporation typically spent bringing a new vehicle to market. Every corner that could be cut would be cut, every compromise that could be made would be made. And that cascading series of compromises is what would eventually set the whole project on fire. Literally, actually on fire, with flames and smoke and fire trucks. Aldikacti's original vision called for an aluminum block V6 engine purpose-built for the mid-engine layout, something with proper clearances, adequate cooling, and genuine sporting power. The cost of developing that engine alone would have exceeded the budget for the entire car. Corporate said, absolutely not. Instead, Aldikacti was handed the Iron Duke, GM's 2.5-liter four-cylinder that had been going into economy cars since 1977, 92 horsepower. That's what they gave a car that looked like it should be doing 150 miles per hour on an Italian highway. 92 horsepower, from an engine nicknamed for being heavy, crude, and painfully slow, a push-rod four-cylinder with a cast-iron block and head that weighed about as much as some V8s. The Iron Duke wasn't designed for a mid-engine sports car, it was designed for the Pontiac Phoenix, for the Chevrolet Citation, for vehicles whose primary engineering goal was to exist without offending anyone. The cost-cutting didn't stop at the engine, not even close. The front suspension was pulled directly from the Chevrolet Chevette, the Chevette, a car whose owners were not exactly celebrating its road manners. The rear suspension and powertrain cradle were essentially lifted from the Chevrolet Citation, complete with tie rod ends attached to a steering knuckle that didn't actually steer anything, just held alignment. The brakes, the steering components, the wheel bearings, all parts bin pieces scavenged from GM's economy car lineup. Chevette owners later discovered they could upgrade their own undersized front brakes using Fiero parts, which tells you something about the relationship between these two vehicles. Aldikacti had designed a proper double wishbone front suspension and an independent rear setup specifically for the Fieros mid-engine architecture. Those designs were killed before production started. Budget reasons. The thing is, underneath all those compromises, the fundamental structure of the Fiero was genuinely innovative. The car used a full steel space frame consisting of roughly 280 separate galvanized and high-strength steel stampings joined by 3,800 welds weighing about 600 pounds assembled. You could drive the bare space frame around a parking lot with no body panels attached. It was fully functional as a rolling chassis, and those body panels were made from a composite plastic material called Enduraflex, non-structural, bolt-on, rust-proof, lightweight. This was radical for 1984. No production car had ever done anything quite like it. The space frame technology would later influence the Saturn S Series and GM's U-platform minivans, and the crash test results were so good that the Fiero became the second safest car sold in America during its entire production run, scoring 5 stars from the NHTSA. Only the Volvo 740DL station wagon beat it. A mid-engine plastic sports car built on an economy car budget was safer than nearly everything else on American roads. Nobody remembers that part. They remember the fires. The name Fiero means very proud in Italian, and fierce or wild in Spanish. They considered calling it Sprint, Pegasus, Sunfire, even Firebird XP. Fiero won out. Given what came next, the name carried unintentional poetry to it. Fire-O. Production started in the fall of 1983 at the Baldwin Avenue plant in Pontiac, Michigan. Bill Hoagland, who had taken over as Pontiac's general manager in 1980, championed the car and negotiated to reopen the shuttered factory specifically for it. He wanted to prove that cooperation between management and labor on the assembly line could work without the robots that GM's top executives were pushing for. Hoagland told his top 36 staffers that Pontiac would rebuild itself with cars that were exciting and different. The Fiero was both. The car debuted as a 1984 model, and the American public responded with something close to hysteria. It looked like nothing else on a domestic dealer lot. Pop-up headlights, a wedge-shaped profile that made people genuinely mistake it for something European. The first mid-engine layout, ever mass-produced by an American manufacturer. Pontiac pitched it with the slogan, "We build excitement," and for once, the marketing wasn't lying. The Fiero paced the 1984 Indianapolis 500, beating out the brand-new C4 Corvette for that honor. Car and Driver put the 2M4 model on their 10 best list. Pontiac ran 3 shifts at the Baldwin Avenue factory and still couldn't meet demand. First-year sales hit 136,840 units. For a 2-seat mid-engine car with 92 horsepower, that number is extraordinary. There was just one problem. Well, several problems, but one that overshadowed everything. On October 6, 1983, before the Fiero was even available to the general public, 2 cars caught fire during routine testing at GM's proving grounds. One of them burned right in front of Hulki Aldikacti himself. The project manager stood there and watched his own creation go up in flames during a test drive. An internal memo went to Pontiac executives that very week, warning about the fire risk. An engineer documented the problem. The memo exists. The warning was on record. Nothing changed. Production continued. The cars shipped to dealers. Customers drove them home. And the fires continued. The problem was a chain reaction of cost-cutting decisions, all converging in the worst possible location. The Iron Duke engine, when squeezed into the Fiero's tight mid-engine bay, needed a modified oil pan to fit the available space. The resulting sump held roughly 3 quarts of oil. Most engines of comparable size and application used 4 quarts or more. The owner's manual and the dipstick in early 1984 models confirmed this reduced capacity, so owners who actually bothered to check their oil saw the correct level and moved on. Many owners never checked at all because most people in the 80s didn't check their oil before every drive, 3 quarts. In a mid-engine bay that ran hot, even under normal conditions. The engine was also prone to valve cover gasket leaks straight from the factory, a known characteristic of the Iron Duke across every application GM put it in. Oil would seep out, collect on the hot exhaust manifold sitting just inches away in the cramped bay, and begin to smolder. Sometimes it caught fire on its own. Sometimes it needed help. That help came from the connecting rods. The rods being produced at GM's Saginaw foundry had serious metallurgical defects. Not a handful of them. Not a bad batch. According to internal GM documents, more than 30% of the connecting rods coming out of Saginaw had casting flaws. Pontiac management knew about this. The foundry knew about this. Fixing the problem would have required shutting down the production line for retooling, which nobody wanted to authorize because it would disrupt supply for every GM vehicle using that engine. The defective rods kept going into engines. The engines kept going into Fieros, and Fieros kept catching fire. When a connecting rod with compromised metallurgy fails under load, it doesn't just stop, it doesn't seize, it detonates. The rod punches through the side of the engine block like a fist through drywall. Hot oil sprays violently across the engine bay, coating the exhaust manifold, the catalytic converter, and any wiring harness within range. In the Fiero's engine compartment, that was everything. The wiring harnesses were routed too close to the exhaust. Battery cables could rub against the engine block and short. The deck lid on 84 models featured an open magnesium alloy grille directly above the engine that collected leaves and road debris, essentially stacking kindling on top of the hottest components underneath. Every element of the engine bay was either a fuel source or an ignition source, and the budget cuts had eliminated most of the clearance between them. By the end of 1985, GM had received 112 reports of engine compartment fires, overwhelmingly concentrated in 84 models. GM's initial response was not to issue a recall. Recalls generate press coverage. Press coverage generates lawsuits. Lawsuits cost money. Instead, according to journalists Joseph White and Paul Ingracia, Pontiac quietly treated engine fires as individual warranty repair cases. Customers who complained were allegedly asked to sign non-disclosure agreements before receiving compensation. Your Fiero burned? We'll make it right. Just sign here and agree to never talk about it publicly. This went about as well as you'd expect. By the summer of 1986, the National Highway Traffic Safety Administration opened a formal investigation. GM tried to minimize the scope and shift blame to owners for not maintaining adequate oil levels. The NHTSA documented the breakdown of fire causes. Among the complaints they had received by late '87, 13 fires traced to coolant leaks, 16 from fuel system leaks, 8 caused by battery cables rubbing against the engine block, 26 from oil leaks caused by connecting rod failure, 12 from electrical wire shorts, and 59 from causes that couldn't be definitively identified. Multiple distinct failure modes, all converging in the same small, hot, poorly ventilated space behind the seats. By mid-1987, the fire rate for 84 Fieros reached 20 per month. The total climbed to roughly 260 documented fires, with 10 reported minor injuries and, remarkably, 0 fatalities. Nobody died. For all the destruction, the headlines, the jokes, and the public panic, not a single person was killed in a Fiero engine fire. The Ford Pinto, the car most associated with fire danger in American automotive history, killed 27 people. The Fiero killed none. But the Fiero fires were concentrated in time, highly visible, happened to a car whose name sounded like it was announcing its own combustion, and occurred at a rate of 1 in roughly every 400 to 500 vehicles sold. The PR damage was catastrophic and permanent. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. Now, the engineering picture of what was happening inside that engine bay deserves a closer look, because it's more layered than most people realize. The Iron Duke had a bore of 4 inches and a stroke of 3 inches, giving it 151 cubic inches of displacement, compression ratio of 9:1. Peak output was 92 horsepower at 4,000 revolutions per minute and 132 pound-feet of torque at 2,800 revolutions per minute. This was a long-stroke, low-revving engine built for fuel economy in front-wheel drive applications, not heat management in a mid-engine configuration where the engine is essentially enclosed in a box. In a conventional front-engine car, the Iron Duke sat behind a full-sized radiator with unrestricted airflow flowing directly across it from the front grille. Temperature management was straightforward. In the Fiero, the engine sat behind the passenger compartment, walled in on most sides, breathing through a compact rear-mounted radiator with restricted airflow paths. Mid-engine cars, by their nature, require extremely careful thermal engineering because heat accumulates around the engine with nowhere easy to go. Ferrari knows this, Lamborghini knows this, Porsche knows this. GM, in 1984, apparently did not find it worth the budget to address it properly. The lubrication situation was the first domino in the failure cascade. 3 quarts of oil circulating through an engine running perpetually warm in an enclosed bay meant the oil degraded faster, provided less bearing protection, and reached critically low levels with even minor seepage. And the Iron Duke seeped. It seeped from valve cover gaskets. It seeped from the oil pan gasket. It seeped from anywhere 2 surfaces met, and a gasket was supposed to keep them sealed. Small amounts of oil accumulating on exhaust surfaces running at several hundred degrees Fahrenheit could smolder or spontaneously ignite. In a front-engine car, a minor oil leak means a spot on your driveway. In the Fiero, a minor oil leak was the opening act to a fire. The connecting rod failures were the catastrophic escalation. A rod with compromised metallurgy, already stressed by marginal lubrication and elevated temperatures, could fracture at highway speed and blow through the engine block wall. This created instantaneous, high-volume oil release directly onto surfaces hot enough to ignite it on contact. The resulting fire could reach the adjacent wiring harness within seconds, creating electrical shorts and additional ignition sources. The whole thing cascaded. Engine fails, oil sprays, exhaust ignites oil, fire reaches wiring, wiring shorts and sparks, more fuel sources catch, and now the entire engine bay is involved. In a well-designed mid-engine car, thermal barriers and proper routing prevent this cascade. In the Fiero, every component was a link in the chain. GM issued the recall on the evening before Thanksgiving. 1987, maximum news burial. All 84 Fieros with the four-cylinder engine were covered. The prescribed fix was almost comedic. Check for engine rod knocks and fluid leaks. Change the oil and air filter. Install a new dipstick calibrated for 4 quarts instead of 3. Install a new radiator cap. Remove sealing material from the deck lid to improve airflow. And affix a sticker to the fuel filler door reading, "Check engine oil at every fuel fill." A sticker. For an engine with a greater than 30% defective rod rate, the recall solution included a sticker. Pontiac also authorized dealers to provide oil changes at a reduced rate of $10 for 6 years or 60,000 miles, whichever came first. A second recall in 1990 expanded coverage to all Fiero model years for additional fire prevention modifications, including exhaust manifold deflectors and revised heat shields. Here's the part that makes the whole story genuinely tragic. While the 84 was burning, the Fiero was actually getting meaningfully better every single year. The 1985 model introduced the 2.8-liter V6 with multi-port fuel injection, producing 140 horsepower, nearly 50% more than the Iron Duke. The V6 had a completely different reliability profile, adequate oil capacity, no connecting rod crisis, almost no fire incidents. A GT trim arrived carrying the new motor paired with a Muncie-built 4-speed manual. Sales dipped to 76,371, a normal correction from the first-year frenzy, but still healthy numbers. The 86 brought the gorgeous fastback GT body that made the car look so much like a Corvette from certain angles that people would actually stop and stare. Sales recovered to about 84,000. The suspension was progressively refined each year. Brakes improved. The engine bay got better routing, better sealing, improved heat management. Most of the problems were being systematically addressed by engineers who cared deeply about the car. And then came 1988, the year Pontiac finally built what Aldikacti had designed a decade earlier. The 88 Fiero received a completely redesigned suspension that cost $30 million to develop and implement. The front got revised double wishbone geometry with new control arms and knuckles that dramatically reduced steering effort and transformed handling feel. The rear threw out every last Chevrolet Citation, hand-me-down, and replaced the whole assembly with a tri-link independent suspension using all new knuckles, trailing links, lower control arms, and tow control links. This was the suspension Aldikacti's team had originally drawn up in 1979 before cost-cutting killed it. Some observers noticed a resemblance to Lotus suspension designs. GM had recently acquired 91% of Lotus, but the Fiero engineering team maintained the design was their own, refined through years of production experience and by what they had learned from the car's IMSA racing program, where a Super Duty Fiero had won the Manufacturer's Cup in '87. New 2-piece brake calipers and upgraded rotors, both items designed from the beginning and cut for cost a decade earlier. Staggered wheel sizes, 15 by 6 inches up front, 15 by 7 in the rear. A new formula trim offered the GT's suspension and equipment with the standard coupe body. The 4-cylinder received a balance shaft and an in-pan oil filter. The transformation was so thorough that car and driver declared Pontiac and America finally had a budget-priced sports car to be proud of. And the performance backed up the praise. The '88 Fiero GT reached 60 miles per hour in approximately 7.5 seconds, quarter mile in about 15.9 seconds at 86 miles per hour. The Ferrari 308 did 0 to 60 in 7.6 seconds and ran the quarter in 15.8 at 88 miles per hour. A Pontiac priced under $15,000 was within tenths of a Ferrari costing nearly $70,000. Imagine buying a 308 and losing to a Fiero at a stoplight. Before that car and driver issue reached newsstands, the Fiero was canceled. Bill Hoagland, the man who had championed the Fiero from the start, had been replaced back in July of '84 by J. Michael Losh, a finance executive whose job was reducing costs and killing anything that didn't make the spreadsheet work. After the recall announcement in late '87, Losh ordered a complete review of the Fiero program. The findings were brutal. Warranty costs, largely driven by the '84 fire situation, meant Pontiac was losing more than $2,000 on every base model Fiero that left the factory. The GT variants were profitable, but not profitable enough to offset the losses. The Baldwin Avenue plant had capacity for up to 350,000 units per year. The Fiero was its only product. A companion program called GM80, a new front-wheel drive platform intended to replace the Camaro and Firebird, had been canceled separately due to its own cost overruns, leaving the factory vastly underutilized. The economics were indefensible, at least on paper. Sales in '87 had dropped to 46,581 units, partly due to the fire coverage and partly because GM reportedly did almost no advertising for the car that year. In '88, just 26,402 Fieros were assembled. On August 16, 1988, the last Pontiac Fiero rolled off the line in Pontiac, Michigan. That final car was presented to a GM assembly line worker and preserved in near-original condition with just over 500 miles on the odometer. In December of 2020, it sold at auction for $90,000 from a car that originally listed around $12,000. A prototype for a second-generation Fiero existed. People saw it. It was displayed at anniversary shows. It was to receive either the new dual overhead cam quad 4 engine producing 190 horsepower as a base motor, or a DOHC V6 making over 200 horsepower for the GT models. A turbocharged Buick V6 variant was reportedly seen at the proving grounds. This was the Hulki Aldikacti had always wanted to build. It never saw production. The prototypes were eventually shipped to a scrapyard in Australia and demolished. Why Australia? No one has ever provided a satisfying answer. Total production across 5 model years was 370,168 units. For context, Toyota sold 163,000 MR2s in its first 5 years. The Fiero outsold its closest mid-engine competitor by more than 2 to 1. It just couldn't outrun its own reputation. Today, the Fiero sits in a strange and somewhat redemptive position in automotive history. The fire jokes never stopped. But neither did the enthusiast community. The car's mid-engine layout and Bolton plastic body panels make it one of the most popular platforms for kit car conversions on Earth. People turn them into Ferrari replicas, Lamborghini replicas, and creations that defy any easy classification. Only 247 Fiero Meras were built as factory-sanctioned Ferrari lookalikes before Ferrari's legal team shut it down. The aftermarket parts supply is enormous. Owners swap in LSV8s, modern turbocharged 4s, and V6s that expose the original Iron Duke for what it always was. A tractor engine stuffed into a sports car body. The '88 models command the highest collector prices. The car GM killed for losing money is steadily appreciating because the enthusiast world has finally recognized what it became in that last year. The space frame technology lived on in other GM platforms. The lesson about starving a good design of the resources it needs lived on even longer. It took Chevrolet another 35 years to try again. The C8 Corvette went mid-engine in 2020 with a proper budget, a proper engine, and a development timeline that didn't involve bolting Chevette parts to anything. Nobody learned that lesson from watching the Fiero succeed. They learned it from watching it burn. Hulki Aldikacti passed away on March 4, 2013. He was 79 years old. George Millidrag, his co-designer, had died in 2009 at 78. Neither lived to see the Fiero complete its slow transformation from joke to cult classic. Neither got to build the version of the car they had actually wanted. The Fiero was supposed to prove that an American manufacturer could build a mid-engine sports car for regular people. It proved something else entirely. That a good idea, starved of money and buried under compromises, will eventually catch fire. Sometimes that's a metaphor. Sometimes it's just what happens when you put 3 quarts of oil in an engine that needs 4 and hope nobody notices. And there you have it. The mid-engine dream that burned itself into history. If you've owned a Fiero or watched one smoldering on a highway shoulder, tell me about it in the comments. Subscribe if you want more of these. We do this every week.